Welcome, guys. So today we are solving the quantum mechanics, simple quantum mechanics problem. Basically, it's the particle in the box. In the box. Okay, so we will consider particle from x, one-dimensional, and box which is infinite potential confined between x equals to 0 and x equals to a. Okay. So we will solve the wave function and the energy. Okay, so let's write down the simple Schrödinger equation. So this is inside the box, right? And the boundary condition is basically the psi of 0 and psi of a, which is 0 because this is potential is infinity, so the box cannot the wave function must vanish at these 2 points. Okay, so this is phi double prime equals to minus 2meh r squared phi. Okay, so basically we can consider suppose e is equal to 0, we will have this, right? But this is double derivative, second derivative equals to 0, so phi is like ax plus b. Okay, so this is impossible, right? Because if phi is linear, then the phi cannot be bound, right? Unless phi is constant, right? But if phi is constant, then the phi of 0 and the phi of a, which is 0, so b is 0. That means phi is 0, right? But phi need to have the normalization to be 1, right? If phi is 0, then phi cannot normalization to be 1. So this is impossible. Okay. Okay, so let me just delete. Okay, and the second possibility is that e is larger than 0. Okay, so let me check. Maybe e is less than 0. Okay, so e is mine. I can let e equals to minus k squared. Or maybe let me just change the notation. Let me change e to be h bar minus 2m k squared. Okay. Then we will have this, right? And this is the second derivative equals to k squared phi. So the answer is cosine or sinh. So it's kx plus b cosine kx. And you can easily prove that because cosine is exponential kx plus minus kx, and this is kx, right? Minus. So basically, when x goes to infinity, then it will blow up, or x goes to infinite, so it will blow up, or x goes to infinite minus negative infinity, it will blow up. So basically, phi is not a bounded function. Phi is not bounded. So what? So phi is impossible, right? Because the wave function need to be normalized. Okay, so we can cancel these possibilities. Okay. Okay, so the only possibility is that e is less than larger than 0. Okay, so let's say e is this one, right? I can let it to be this. So we get phi double prime equals minus k squared phi. So we have phi equals a cosine kx plus b sine kx. Okay, and the phi of 0 equals to 0, and the phi of a equals to 0. So which tell you that what? If phi of 0 is a plus b sine ka equals to 0. Oh, 0, right? So this is a. You tell a equal to 0. And this is so a is already 0, right? So you tell b sine ka is 0. But b cannot be 0 because a already be 0. So sine ka, which is 0. Okay, so sine ka is 0, tell you that ka is n pi, right? N is integer. Okay, 1, 2, 3. N cannot be 0, right? If n is 0, then k is 0. Then we get the same thing, right? So that means k cannot be arbitrary, right? So k is 2me divided by h bar square root equals to n pi divided by a. So this is pi. So we have 2me h bar square n square pi square a square. So e is n pi square h bar square 2ma square. So this is the energy. So energy is proportional to n squared, and n is 1, 2, 3. Okay, so now we solve the energy. Okay, then we can solve the wave function. Okay, so now what, right? So now we got this, right? So that means we can solve the wave function, because wave function is just something times sine kx, right? And I already solved k, so k is only n pi divided by a. So this is the only possibilities for k. So k is quantized from n is 1, 2, 3. Okay. So this is the b sine n pi divided by a x. Okay, so let me one may ask, n can be right, but you can see that if phi is negative, if k is negative, then this is the same as phi is positive, because there's only a constant, only a phase about a wave function. Okay, so we only care about k n is positive. Okay, so the remaining is to find b. Okay, so we can do a normalization. Okay, we just take a square and do the integration from 0 to a. So we have 0a and the b square sine square pi square dx. Okay, so this is a b square 0a sine square n pi divided by a dx. So this is just a half 1 minus cosine 2 n pi divided by a dx. Okay, and you can easily check that this turns 0. This turns 0. The reason is that you can just use direct integration, but basically this is cosine, and you're integrate the 1 period. Okay, so you get b squared 2a equals to 1, so b equals 2 over square root of a. Okay, so the results mentioned here. So basically the phi n is 2 to the a, 2 square root of a sine n pi divided by ax, and the en is just n squared pi squared h bar squared 2ma squared, right? Okay, so this is the result of the particle in the box. Okay, so that's it. I will see you guys in the next quantum mechanics video. Be sure to subscribe to my channel. Thanks.